welcome to another lesson. This is page 8 of our notes, and today we're going to be doing a lot of simplifying by using the rules of fractions. So a lot of students find fractions a little bit intimidating, a little bit scary, but hopefully when you get to the end of this video you'll feel better about fractions than maybe you do right now. So let's get right into it. What are we going to do first? We're going to solve for what's called equivalent fractions. And more often you just think of this as simplifying, okay? So I'll just read what it says here first. So the fundamental principle of fractions. It says the value of a fraction is unchanged if both the numerator and the denominator, so just a quick reminder, numerator, so the top and the bottom, are multiplied or divided by the same number or expression, provided that number is not zero. So we can't divide by zero. So what does this mean? It means that we can kind of change fractions any way we like and eventually simplify fractions as long as we're dividing by the same thing on top and bottom. So what does it say here? It says two fractions are equivalent if one is obtained by using the other with the fundamental principle of fractions. So again, what does that mean? Well, it says here, for example, 2x squared y over 5a is the same as 2x power 4y 5a x squared, because something happened to the x terms here. They're equivalent fractions. They're equivalent because we can take the first fraction here and multiply it by x squared on top and bottom. So let me show you what it means. It took the first fraction, it took this fraction here, okay, that fraction, and it's multiplying on top and bottom by x squared. And that's allowed because technically this equals 1, okay? Technically this whole expression, x squared over x squared, is 1. We know they cancel out normally. So really we're actually just multiplying by 1. And if we then combine all of our terms, we get something that looks like this, 5a x squared. So it's just saying that fractions can kind of be manipulated if we want to by multiplying on top and bottom by the same thing. Now, that works way more usefully going the opposite way. So let me make a note of that. This whole idea of equivalent fractions is more useful if we do the opposite process. So what it means here is essentially if we look at a fraction and we see something on top and bottom that matches, you can cancel them out and reduce to lower terms or simpler terms. And that's what this next block of text is saying, and then we're going to get to an example. So it says a fraction is said to be in lowest terms if the numerator, so the top and the bottom, have no common factors other than 1 and negative 1. And it says to reduce a fraction, so this is really, really, really important, this last step. To reduce a fraction to lowest terms, we use the fundamental principle of fractions by dividing both the numerator and the denominator by all factors that are common to each. Usually, it's much easier to figure this stuff out when you have an example, so let me give you an example. So this example here says reduce this to lowest terms. So we need to reduce the numbers down, cancel as much as we can, reduce the letters down as much as we can, and see what the equivalent fraction is. So the first thing I would do if I were you is look at 16 and 24 and see if we can divide something out. So what are the factors of 16 and 24? We've got 1 and 16, we've got 2 and 8, we've got 4 and 4. So my factors of 16 are 1, 2, 4, and 8 and 6. If you do the same thing for 24, the factors of 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So these are all of our fractions. Sorry, all of our factors. What is the greatest common factor? What's the biggest factor in common between these? Well, if you look carefully at the lists, we have a 1, we have a 2, but we have a 4 as well in both lists. 1, 2, and 4 in both lists. But the greatest factor in common, the biggest factor that they both have in common, is this 8. So that's what we call the greatest common factor, the GCF, which I've talked about before, but not quite in this situation. What's my point? My point is if we take these numbers and divide it by the GCF, we'll get the smallest possible version of this fraction. So let's divide them both by 8. 16 by 8 is 2. 24 divided by 8 is 8. Sorry, is 3. All right? Let me just give you a little tip here too. You can do this on your calculator. There's two ways to do it. First, I'll get the Casio up. And this pretty much just gives you it. You can set it up as a fraction. My calculator looks a little weird, but 16 divided by 24, if you put that in your Casio, it'll either give you a decimal, or if you click the S to D button, so standard to decimal or a fraction to decimal, mine looks weird, but it means 2 over 3, okay? So it actually does it for you. If you have a TI calculator, you can do much the same thing. So you take 16, divide it by 24, you got that in, press enter, it gives you a decimal, but let's not forget that this calculator is really powerful. You can go to math, and it says make it a fraction, arrow to fraction. So it'll turn what you have already, your answer, into a fraction. And it'll very conveniently be in simplest form, which is 2 over 3. So when in doubt with your numbers, just use a calculator. It's much faster, and you don't need to mess with your greatest common factor trees. Okay? So that's our numbers. What about our letters? Well, on top and bottom here, we have A and A, so they can cancel. What about our b's? We have 3 on top, 2 on bottom. So just by basic exponent rules, we can use this. We've done this before. B cubed over b squared is the same thing as b power 3 minus 2, which is just a single b, right? So it cancels out the top b, cancels out the bottom. And then what about c's? Well, 2 off the top are gone, and 2 off the bottom are gone, leaving 3. Long story short, what I end up with on top is 2b, and on bottom, I have 3c cubed. All right, hopefully you can see that. The 2's and 3's came from our blue. Our b, I worked with red, and our c's, I worked with green. Now, I won't color code everything, but just in case you're having trouble figuring out where that all came from, that's where it all came from. Let's continue. Let's try a question that looks a little more like what we've been dealing with lately. Here it says you can only cancel factors, not terms. What the heck does that mean? Well, it means that in this situation here, we see that there's an x on top and an x on bottom. That could cancel out, leaving x plus 2. But, and this is a huge problem for a lot of students, this x on top is not able to cancel with this x on bottom. And why is that? It's because you can only cancel factors, which means like sets of brackets, and this kind of has some hidden bracket here. One way to think about this is if you don't see brackets on the top, like this, like you see there's clearly brackets here, if you don't see brackets on top, you have to treat the whole top like a set of brackets. Okay, treat the top and the bottom, or the bottom, as one big set of brackets. And why is that relevant? You can only cancel it if the entire top matches the entire bottom, or if the whole top cancels with something on the bottom, okay? So just keep that in mind. A lot of students say that the x's cancel and it gives 2, and that's just not right. It's not correct. We can't do that. We can only cancel it if there's a really clear boundary of things to cancel, and usually you look for the brackets for that. Let's do some examples to let this settle in our brains. So it says reduce the following to lowest terms. Well, we should treat the top and the bottom separately. So I'm going to look at the top and say, how the heck do I factor that? And if you look at just the top, you should hopefully see that that can be factored out as a common monomial. A 6x is common to both of those terms. So take out a 6x, and what are you left with? You're left with an x minus 2. How did I get that? Well, 6x divided by 6x squared divided by x. Take the 6 out, take one of the x's out. In this case, the 12 was divided by 6, leaves a 2, and the x was taken out, so x minus 2. On the bottom, I have an x minus 2. Now we have a really nice situation. We can cancel this. We can reduce this to what's called lowest terms, because look, the whole bottom can cancel with this bracket term. And why am I allowed to reduce the bottom with the top? You can think of the whole bottom as one big bracket, and it would then cancel with that one big bracket on top. So what am I left with? What's the only thing that didn't cancel? Well, that's our 6x. So I want to make a note here. I want to say, as always, try to factor the top and the bottom first. Okay, something very important to keep in mind. If you do that, this will start getting easier and easier. The second question here, B. I'd like you to pause the video and give it a shot. Okay, so that's your time. You've had your time to pause the video. What are we going to get? Well, some students write down that 2a must cancel on top and bottom and leave 1 over x. And that's definitely not correct, okay? That would be really sad, because students would say 2a cancels with 2a on bottom. It's just not true, because it's not equal to that. Why? Because you need to cancel the whole top with the whole bottom in that case. You would have to have 2a cancel with the whole thing, 2a plus x, and it's just not going to happen. There's nothing to cancel there. There's not enough to simplify. So in this case, we can't simplify. It says can't be simplified. So there are cases, just like sometimes you can't factor, there are also cases where you can't simplify it. I'm usually not going to give you cases where they can't simplify, but it's really important to know that at least that is possible. It is possible not to be able to simplify, okay? So let's look at the next one, C. I'll zoom in a little bit. What are we going to do in this case? Well, just look at C. We're going to try to factor the top and bottom separately first. So the top, there's really not much I can do on the top. That's a 2x, 5x minus y. There's nothing I can do. But the bottom, I can do a common monomial, okay? So the bottom, I'm going to do common monomial. Take a 2, left with x plus 2. Do you see anything that can cancel? Well, the brackets can't cancel, but hey, look at those numbers. Those numbers can cancel. There's a 2 on top, there's a 2 on bottom, and I've got something a little nicer than what I started with. And there we go. So that's how I simplify that one. Let's try the next one. I recommend that you pause the video and try this next one and see what you get, okay? Try factoring the top and bottom separately. See what you get. Hopefully you've got that a shot. What you'll get is x minus 2 on top, x plus 2 on bottom. So let's see what we can do. First things first, the top, I'm going to factor that. You're going to see that that's a trinomial. On the bottom, hopefully you've noticed that's a difference of squares. For shorthand, later, I might end up just calling this tri, and I usually like to call this DOS, which means difference of squares. But, you know, if I use that shorthand, try not to get confused. So factor the top and the bottom separately. The top one's a trinomial, and we need 2 factors that multiply to make 4 and add to make -4. So that would be -2 and -2. So take your time and get that if you need to. On the bottom, that's a difference of squares. It's x squared minus 2 squared, which means it's x plus 2, x minus 2. And now we've got another nice situation where something can cancel. What's going to cancel is we have x minus 2 and x minus 2 on top. Maybe I'll make that a different color just so it pops. X minus 2 and x minus 2, that just gives us a 1, right? Because the top and bottom are the same. We don't need to write that 1. We can just say we have x minus 2 on top, x plus 2 on bottom. In our final answers, we usually remove the brackets, although if you really want to, you can keep those brackets in. It's just not like standard, it's not proper math, I guess. It's not proper notation, but there's nothing wrong with that. But just to keep the final answer there complete, just to keep the final answer neat, I will leave it at that. Okay, let's do one more on this page. X over 7x minus x squared. So what do we have to do? Well, as usual, we're going to factor at the top and factor the bottom. There's nothing to do on top, so just leave the x. But on bottom, I have a common monomial of x. It's going to be 7 minus x when I'm all done. What do I do next? Well, I take this x and cancel this x. And then what's left on top? Well, when everything gets deleted from the top, really, that's when the 1 comes out. Okay, there's still a 1 left over here. Maybe I'll make it more clear in this color blue. There's still a 1 left over. It's just we don't usually see it because it's pretty rare for things to totally cancel. But I'm going to keep that 1 on top, and then we get 7 minus x on bottom. Occasionally students will write this. When the x's all cancel, sometimes students write 7 minus x. and it's not that. All right, just something to keep in mind. It's not 7 minus x. They don't just cancel and then it just disappears. So be careful. If you feel like you're going to fall into that trap, well, please try not to fall into that trap. That's it for this page. Let's see what else we got on the next page. It's talking about factors that differ only in sign. Now, what the heck does that mean? Like, what are they talking about? Well, what it means is if you have something like x minus y and y minus x, notice that they're just kind of like a flip or an opposite of what we start with. That's what we call it differs in sign. It's the same expression, but it's been multiplied by -1. Or in other words, a -1 has been taken outside of it. So if you flip the signs and take a negative outside. Really what this is going to mean for us is if we notice that the top and the bottom are in opposite order, or they have opposite signs, what I mean is, in this case we have a plus x and a minus y, and on bottom you can kind of see that we have a plus y, a minus x. The signs are different. That's when we can cancel them and just it pops out a -1, okay? So what does this look like in practice? Well, first of all, I'll show you what it looks like in this case. X minus y and y minus x. I'm just going to write this exact same thing out for you again. Notice that the x minus y and the y minus x is the exact same thing. It's just opposite direction, right? They're just in different order. What we can do here is really nice. We can cancel the top and the bottom, and instead of it turning into 1, it leaves a -1. That's the trick here. So it just leaves a -1. That's why it gives us this -1. Let's see it in practice. Let's simplify this. How does what I just taught you apply to this question? Well, first of all, let's factor the top and see what we can do. All right, the top is a difference of squares. Okay, the top here is a difference of squares. And if you work through how to do the difference of squares, and you will get faster, this is x plus 1 and x minus 1. Please pause the video and check that yourself if you don't believe me. On the bottom, we have 1 minus x. It looks like we can't simplify because it looks like we don't have any common factors, but we do. On top and bottom, we have a factor that differs only in sign. Which factor is that? It's x minus 1 and 1 minus x. If we cancel those, because they're just in different order, it will pop out this -1 term. How does that help us? Well, we still have our x plus 1, but in this case, it's just going to have to be multiplied by this little -1 that I had there. Now, what do I do like this? How do I write a simpler version of this? Well, the -1 just kind of comes in front as a negative sign. Okay, so at the end of the day here, we're just going to say it's negative x plus 1. So it's still that x plus 1 that we got after the simplification, but it's got this little negative hanging out in front. There is one other way that you could write this, and some students prefer it. They don't like to see brackets in their final answer as much, and that's okay. And the process we're going to follow is we're just going to multiply in the brackets by this -1. Okay, that's what I'm about to do here. So if you multiply through, maybe I'll write it down here. We know that this is our final answer. We can actually make that equal to, multiply. It'll give us a -x minus 1. And some students write that as their final answer, and that would be okay. There's nothing wrong with that. You're just kind of doing a little extra work that you didn't need to do. So this question's finished. I'm going to move on to the next question, and I'm going to brace you for this one. This question looks crazy complicated compared to what we've done before. I'm going to treat the top and the bottom as their own problems, okay? And then let's see what falls out of that. So take the top, that's 2x power 4 minus 128x. And then just while I'm writing this, I'll take the bottom, I'm going to write that over here, and in a little while I'll come back to that and do that as its own problem. By the way, for those that want to work ahead, the final answer to this, believe it or not, is -1. So if you want to work ahead and you can get -1 as your answer, then, you're a superstar in my books as far as I'm concerned, but this question is quite tricky. So why did I do all this? Well, first, I'm going to deal with the top and the bottom separately, and actually I'm going to give myself more space and put this over here, because this problem gets pretty big pretty fast, and I don't want to have to do a lot of adjustments along the way. So let's just treat the top as its own problem. What would we do to factor this? Well, I can see that there's a common factor of 2. That would factor out 2 out of that. It would divide everything by 2. And then I've got a common factor of x. That leaves x cubed minus 64. What do I do now? Well, this part here, what is it? Do you know? You see a cube there, you see a minus there. This is a difference of cubes. And I'm not going to write the formula. You can go find the formula in the previous pages. We've done quite a lot of it. But I'm going to use the formula to work out this answer. Okay, 2x stays on the outside. And if you use the formula on this piece, this is what you're going to get. You're going to get x minus 4, because 64 is 4 cubed. Then it's going to be your x term squared plus your x term and your y term, which is 4x, plus 4 squared, which is 16. Now again, I'm just using the formula. I'm not showing you the formula, but this is the formula. This is following the rule of the formula. Okay, so go ahead and use the formula. Figure that out for yourself, please. And then that is going to be my top. I will put that into my question again later. Now I need to do the bottom as its own problem. So what do I got? I've got a trinomial, and this is actually a pretty tricky trinomial. Look, it's backwards. It's like written backwards. So I want to fix that right away. I'm going to rewrite it. I'll rewrite it first. So I'm going to put my square term in the front. I take my x term in the middle and then my constant term on the end. That's the way I'm used to seeing it. So I'm going to force it to look like that. It still doesn't quite look right. So what's going on here? I've got this negative. So I'm going to say take the -1 or the negative outside. That'll force the brackets to look like what I want it to look like. If you're wondering what the heck I mean by taking a negative to the outside, it means just essentially multiply everything by -1. Bring the negative outside and then all the signs change. You've multiplied them all by -1. So that turns into a positive. The positive 7x turns into a negative 7x, and the positive 20 turns into a negative 20. Now I've got something that's in my form where a is not equal to 1, so I'm going to do my slide divide rule. Okay, so I'm just going to treat this problem as if this is where I started, and I know this is quite a lengthy problem, but this is something that's useful because we can do a lot of steps. I can show you a lot of different steps and cover a lot of ground at once. So slide divide, take 3 times 20. Gives us this. Take some time, figure out what the factors are going to be. Two numbers that multiply to make -60 and add to make -7 are -12 and 5. Pause the video and check that yourself if you're afraid that you won't be able to get that yourself. Okay. Now, in order to do full slide divide, I need to divide by the number that I slide with in the beginning, which is 3. Now I'm almost done. I can see here that the 12 and the 3 are going to simplify, and the 5 over 3 is not going to simplify, so I'll bring the 3 up. And then at the end of the day, I finally got my solution that I was looking for. This is 3x minus 12. Oops, no. This is x minus 4. Sorry, I almost made a silly mistake there. And now 3x plus 5. All right, this I'm going to make blue because I'm thinking ahead here as to what I want to accomplish. So I've done 2 pretty significant problems that follow from what we did in previous videos and previous classes. So this will be the top, and this will be the bottom, okay? I'm going to rewrite that as a fraction. And I know it seems a bit ridiculous, I'm not going to lie. It's not like super simple to do that, but we've done it for a good reason. Let me show you. I'll write the top here. Now I'll write the bottom. And we'll see what we get. I made a very large mistake when I said that this was going to be -1. I'm sorry. For those of you that tried it and are beating your head against the wall, my, what a day this is. That's for the next question. Okay, the answer is going to be much more complicated. I'm really sorry about that. It's been a long day. So now that I've written the top and bottom, as I found it before, now the magic happens. I can start canceling things. How do I cancel things, you might ask? Well, this is what we're going to do. X minus 4 cancels with this x minus 4. It's actually the only magic in the question. There's no more magic. Once I do that, my top is 2x, x squared plus 4x plus 16. My bottom is negative 3x plus 5. So negative 3x plus 5. There is a better way to write that. That negative is sort of not supposed to be down there. It's not proper notation, okay? So that negative should really go to the top. So I'm going to say or. Final answer would be negative on top. I'll just throw it on top. And the bottom would be 3x plus 5. And because that's the only thing on bottom and there's no sign outside of it, we don't need to include the brackets anymore on bottom. So that would be our better answer. I would accept the top one, but this is the better version. So that is a very long question. That's quite difficult. So I'm going to say make sure you take the time to understand this question. Now, C, the one that I kind of fumbled earlier. What the heck are we going to do for C? You might be asking that to yourself right now. Well, I've got the solution for you. Never fear. What are we going to do? Use that rule of the whole negative sign thing. What's the official name? Factors that differ only in sign. I'll do it color-coded so you can see exactly what happens. Look for x minus 3 on top and bottom. Do you see an x minus 3 on bottom? You might not, but I see a 3 minus x. X minus 3, 3 minus x. They differ only in sign. That's going to pop out a negative 1. Let's move on. X minus 1. I see a 1 minus x on bottom. That's going to give me a negative 1. What about x plus 1? I see that exactly on bottom. That's there and there. That's just going to pop out a 1. And then finally, 2 minus x. I see a x minus 2 on bottom. So that's going to give me a negative 1. So when this simplifies, this is what I have. Negative 1 multiplied by a negative 1 multiplied by a 1, which really could have been ignored, multiplied by a negative 1. What's negative 1 times negative 1 times 1 times negative 1? Well, it's an odd number of negative 1s, which means it gives me a negative 1. Okay? If you want like an intermediate step there, some of you might be a little rough on your signs. Try this. Negative 1 times negative 1, that's positive 1. 1 times negative 1, that's negative 1. And what's 1 times negative 1? 1 times negative 1 gives negative 1. So that's where that comes from. So even though that was a scary question to begin with, turns out not all that difficult in the end. We're going to move on to page 11, which is the last page we're going to do in this video. And it looks like a whole new topic. It's talking about multiplying and dividing fractions, but really it's very, very similar to what we just did. There's a tiny little bit extra that you need to understand. So let me just set it up. Multiplication of fractions in algebra, similar to multiplication of fractions in arithmetic. What that means is when you have two fractions, for example, a over b times c over d, what that really means is that the a is multiplied by the a, okay? So let me look at it this way. You do the top multiplied, it gives you AC, and then you do the bottom multiplied, and it'll give you BD. Okay, so what it means is whatever's on top, they multiply. Whatever's on bottom, they multiply. There's another way I like to say that. It's tops multiply and bottoms multiply. Okay, so as long as the bottom isn't 0, this will work out, but usually we don't have to worry about the bottom being 0. So in this example, it's just explaining that 2 times 5 is 2 times 5, which is 10, and then 3 times 7, 21. So in algebra, it's very similar. So the steps are going to follow to multiply algebraic expressions or algebraic fractions. These are the steps. We're always going to try to factor first. and then we're going to cancel all the factors, and then we're going to multiply. So let's see what that actually means with help from this example. So first things first, factor. So this example A, we're going to factor that first. Factor every single piece. So the first piece here, this is a common monomial I'm going to take out. This has got no factoring involved. There's no factoring involved at all. This one here, there's no factoring. And this one here is also a common monomial. All right, so let's do that piece by piece. One big fraction times one big fraction. So the 3x plus 6, pull the 3 outside, you get 3 out of x plus 2. I told you that the next one can't be factored. On bottom, on the left, 5x can't be factored. And then the bottom right, common monomial, I can take a 2 outside, it leaves an x plus 2. So what we'll notice now, we treat this as one big product and treat the bottom as one big product. What are all my terms? Well, this is the only time I'm going to write it as one big fraction, but this can help a lot of students, okay? So I'm going to rewrite the top, 3 times x plus 2 times 15 x squared y. That's one big product, okay? On the bottom, I have what's the same thing as saying 5x times 2 times x plus 2. And now maybe it's easier to see what cancels. Can you see it? You have x plus 2 on top and bottom. You have x's on top and bottom. And then you have 15 divided by 5. 15 divided by 5 gives you a 3. Now, I prefer to see that the way I wrote it before. I'll write out that final answer in a second, but let me look back at this and see what I would do. Same story. I would say there's an x plus 2 on top and an x plus 2 on bottom. I have a x squared on top and an x on bottom, so one of the x's goes away on top and the other x on bottom goes away. And then I have 15 divided by 5 gives a 3. All right, so what I'm left with on top is a 3, an x, and a y. 3 times 3 times x times y is 9xy. So on top, I have 9xy. On bottom, what's being multiplied? I'm looking at this step, right? What's left on bottom? It's just 2. 2. This is the end of this question. Now, you might be wondering, did I follow the steps? So to multiply algebraic fractions, I need to factor the numerators and the denominators. Well, I did. I factored all 4 pieces. 1, 2, 3, 4. All of those pieces were factored there. So I did that. Did I cancel all common factors? This was the cancel stage. All right? That was me canceling things out. The stuff I did in pencil here was an alternate version of that. You could write that all out under one big fraction if it helps you. So I did that as well. And then multiply the remaining fractions. Well, that was when I saw, that's this step on top, that I saw that I had a 3 and a 3 and an x and a y. I multiplied those together, got 9xy. And then the bottom, if there was anything left besides a 2, I would have multiplied it, but there wasn't, so I didn't. That's the whole step. So B, I would like you to try yourself, okay? The final answer for B, I'm going to write this out. I'm going to give you a hint as to how to set it up. This is the final answer. And I know that this one's right this time. I didn't make a mistake. So this is our answer. I recommend you pause the video and give that one a shot, okay? Try it, like, give it a real try. Don't just pretend to try it and then get stuck right away. Like, take 2, 3, 4, 5 minutes if you need to. See if you can figure this out, because if you can get it, it means that you know what you're doing, right? I will do this, but it's really important that you take the time for yourself to figure this out too. So how do we start? First things first, I'm going to factor every single piece, every numerator, every denominator. This piece here is going to be difference of squares. This piece here, trinomial. This piece, common monomial. This piece, trinomial. 4 different types of factoring in the same question. If you haven't been practicing your factoring, this is going to really strike you as something very difficult. but hopefully you have, and it won't be too difficult. So I'm going to set up two big fractions. I'm going to start in the top left because it just makes sense. That's a difference of squares. Hopefully you know by now that if it's x squared minus 1, the answer is x plus 1 and x minus 1. You can just take that for free. If you recognize it, put it in. And let's just go ahead and do that one next to do the big fraction. What do I have in common? I have 2x, and that leaves us with x minus 3. You've done many of those. Again, pause the video, try it yourself, really get into the nitty-gritty with this because it'll help you. The top right here is what I'm going to do next. That's a direct fraction, or that's a direct factoring because it's an a equals 1 form. This is going to be x minus 3, x plus 2. Negative 3 and 2 multiply to make negative 6. Negative 3 plus 2 is negative 1. So that's why that works out. The last one, what's it going to be? Two numbers that multiply to make negative 3 and add to make positive 2. That is positive 3 and negative 1. Check it if you don't believe me. The whole point of this process is to make life easier, and this is where it starts to cancel out, and it's very satisfying once you learn how to do this. What's going to cancel? I look at x plus 1, I don't see any x plus 1s on bottom here, but I do see an x minus 1 on top and bottom, so x minus 1 and x minus 1 cancel out. What about the next one? X minus 3. I see that on top and bottom. Is there anything else that I can cancel? Well, I see x plus 2, but I don't see any of those on bottom. I see a 2x on bottom that I don't see on top. X plus 3 on bottom, I don't see one of those on top. So it looks like I've come to the end of the road here. So all I need to do is write what's left. On top, make a big fraction. On top I have x plus 2 is still there, and I have x plus 2 is still there. X plus 1 on top, x plus 2 on top as well. On bottom, it looks like I've got a 2x left over. It hasn't been canceled out. I've got an x plus 3 left over. It hasn't been canceled out either. And that's as simple as it gets. There's nothing I can do to make that any nicer right now. Maybe I'll clean this up just because I can. And there we go. Did I follow the steps? First things first, factor numerators and denominators. I did. I had to do four different factorizations. Second step, cancel all common factors. That was this step. I canceled these, so I've definitely factored them and I've been able to cancel. Final step, multiply the remaining things. So I took this, multiplied it by this, and I got this. And then I took this and this, multiplied them together, and I got this. So hopefully that's making some sort of sense. That's it for today's video. I hope that you learned something. I hope it wasn't too confusing. And as always, please, if you need anything at all, just let me know. Send me an email. I'll be happy to get back to you as soon as I can. Have a great day, and I'll see you in the next lesson.